come? It has been quite a secret, it seems, about China's development of the quantum technology. Only recently, suddenly, a quantum satellite being launched. What a surprise.
Yes, we play the leading role in this field, but the best scientific result comes from the best crew. We have this leading role just because we have the team led by Professor Pan Jianwei, who is the chief scientist of this mission's satellite project. And he also plays a leading role in this field in building the ground networks. So this is the main reason, I think, for the reason that we have launched the first quantum experiment satellite.
Okay, Professor Yang from the UK, are you surprised being a reader of quantum development from afar in Lancaster?
I'm not surprised at all, no. I think China have invested quite correctly a large amount of money into this field, and it's extremely important. We communicate every day over media like the internet, and we believe that our communications are secure, and that's really not the truth at all. The internet is really a very insecure place, and technologies such as this satellite, which have been launched by China, are really, really important in redefining what we think of as being secure communications.
We need to probably explain to our viewer a little bit as to why, with quantum, it is supposed to be secured communication. So Professor Horack, probably you can help us to understand better about why it is going to be guaranteed as safe.
Well, the details may be beyond the scope of our show, but you can think of it this way. We rely in the current environment on security largely because we build security platforms that take computers a long time to hack. And as it's almost like your password on the computer. If you type a longer password or you add more characters, it can be harder to decode. This takes the security out of the realm of numbers and puts it into the physics of how the universe operates. And we have a saying, you can't fool Mother Nature. And so by using the quantum properties of nature, you you have the ability to put the security in a totally different domain that is just much, much harder to exploit. And in fact, from the scientific perspective, is not hackable at all.
Right. I mean, it really helps us in a way with the quantum entanglement, because it's a process not likely to be detected by a third party. If a third party does detect that, it's going to change, and therefore all the other two parties going to understand that there has been change, and therefore they can just throw away those informations as trash. So let me go to you, Mr. Ghosh. How much is China in advance, given the knowledge that you have over the other places? I understand there's Canada, Japan, and UK, some of the other countries also trying to develop this communication method.
So let me just talk a little bit about the previous question.
Sure,
because
briefly.
I think there's a very interesting point here. A lot of the hacking, the cybersecurity issues happen during transmission and during access. But a lot is due to human factors. People who are in the system, have access to the system, they leak documents. So you have a lot of cases like that, Edward Snowden. Many cases where spies who are supposed to be not leaking information, leak information. So though this is a very promising technology, it does not address, it will not address the human factor. People who have access to the system, leaking system. So we need to also take into account that. A lot of times that is the case. Okay, the answer to your question, yes, of course, okay. China is really, really ahead here. Perhaps there are other countries in the fray, but China is really showing the way here. But there are some other caveats to still remember. The communication speeds are still maybe 1,000 times or more lower than for commercial operations or realistic operations. Also, the transmission distances are not as much. And then, of course, there are storage limit solutions. So this might be a technology which might take as long as 10 years to come into fruition. So it's also important to remember that this is not going to happen tomorrow. will take a little bit of time, but of course, when it happens, it will change the paradigm of computing. Paradigm of telecommunication.
I'm sure among the audience members, they are much more sophisticated technologically speaking than I am, but as far as I understand, there has been a plan. The plan is, Professor Yang from the UK, by the year 2020, China is likely to establish a China-Europe communication way using quantum technology and communication. How would that work, given what Mr. Ghosh just challenged a few seconds earlier?
Well,
let me have Mr. Yang from Lancaster.
Let's
have Mr. Yang from Lancaster.
Okay. Oh, sorry.
We got two Mr. Yang over there. All right.
Yes, so you're entirely correct. So basically, on board the satellite, there's essentially a laser which produces two beams of entangled photons, and these are directed at ground stations on the Earth. So one of these ground stations can be a center in Europe and one in China, and it can link the two places together, which have existing quantum networks based on fiber technology. And allow these two places to communicate securely. Now, just challenging one of the points that was previously mentioned, of course, the data rates now are very low. But actually, for the most secure information, you don't actually need to send very much data at all. So it is a useful technology for specific applications.
Mr. Yang here in Beijing, what do you make of it?
Mr. Yang in UK is right that we do not need to transfer all the data from the quantum technology. We just need to transmit the key. If we have an absolutely safe key, we can have traditional communication measures to transmit the data very safely.
And now when we transfer the key, it could be in a dangerous process because it can be easily detected by the others. But when it comes to quantum technology, once it's detected, everybody knows.
Well, China has already established the technical demonstration lines between Beijing and Shanghai, very long distance, about 1,000 kilometers. But this time we launched a satellite to test the technology to transmit for several thousand kilometers. This is to build the intercontinental quantum communication lines. So that's the point to be practical in 2020, I believe.
May I ask Mr. Yang here in Beijing, why China and Europe? China is not thinking about China and some of the other Asian countries, China and the United States, or China, South America. Why China, Europe?
Well, I'm a technician, but maybe because I guess maybe because Europe and China is in a long distance. For you see, in Asian countries, we do not need to test this technology because in the China is big enough. So in the mainland China, we can test the technology for transmission through the optical fibers. That's good enough. So, but maybe for even longer distance, we need another country to test the, as I mentioned, the intercontinental communication level.
What would that mean, Professor Horack, this quantum communication eventually for the science community around the world? Will China be able to work with others, do you think? And will others be interested in working with China to cooperate on developing these technologies, given the fact that it could be used for military, it could be used for government secrecy? Is there a space of cooperation?
So the answer to your questions are yes and yes. This is a fundamental feature of everything we do in space, in space flight, and that is that much of our technology has multiple uses. Wernher von Braun, the German rocket scientist who came to the United States after the war, described it as like a knife. And if I choose to cut my meat with it, or if I choose to steal your purse, that's my choice. And this is really harkens back to the comment from Washington, D.C. too, that the usefulness of this technology is a function of humankind's ability to use it, and it's my hope and my belief that we are made better by sharing and collaborating in building a better world. And that's why spaceflight is so exciting. This was a science 100 years ago that the only tools we had were pencil, paper, and the human mind, quantum mechanics. And now we're actually able to build systems to not only probe further the nature of the universe and how things work at the quantum scale, but actually to leverage these, the blueprint of our creation, of the universe, to facilitate communications, transportation, economies, and a better quality of life for everyone. So I look forward to collaboration.
They say how time flies, but here we should say how much technologies really flies. It really changed a total thing. I saw the lights in your eyes and your enormous amount of gestures earlier, Professor Horack. I can tell how excited you are as a scientist yourself. But Mr. Ghosh, you seem to be a little bit skeptical while Professor Horack was explaining the prospect. Are you?
Right. So I am. Yeah, so when he's explaining, he's right. I mean, as a scientist, I feel we should be sharing information and going together in the voyage of discovery. But this is a dual-use technology, what we call. So it can be used in war and it can be used in peace.
But Mr. Ghosh, let me just ask you. Aren't technologies, almost everything can be dual used?
Right, that is right. But, but you know, the bottom line is the political leaders and the government sets what we share or what we don't, right? So it's not up to engineers, it's perhaps up to the political leaders as to which of the technologies they deem they would share and some they won't. So sometimes it defies reason, sometimes it is very common sense, but the decision belongs to perhaps the government here.
I can tell, particularly coming from your personal experiences, I'm sure. Having said that, though, what would that mean eventually? Professor Young from the UK, when we talk about the quantum entanglement and the development of it, and now more experiments, about 600 kilometers long kinds of experiments, what would that bring to us in the near term? Can you paint us a picture?
Well, yes, and I'm really passionate about the future of, I guess, quantum technologies in general. This is a key milestone for the development of quantum technologies. And I think, you know, if you look back 100 years, we had the Industrial Revolution, we've had the computer revolution. I think there's a quantum information revolution coming. So the first application of this is in secure communications. We have this first satellite. We're going to have a network of satellites, and eventually we will have embedded electronics in our mobile phones, in our laptops, which handle quantum information and enable secure communications between all the devices in our lives. But in the future, this field of quantum information is going to go much, much further than this. We have secure communications, but we also have the prospect of quantum computers based on the same technology. And these will be computers which are vastly more powerful than the systems that we're using at the moment. They'll be able to solve problems that we can't even dream to solve with current computers. And then there'll be quantum sensors. There'll be devices which are able to detect things like gravitational waves, GPS signals with far more sensitivity than we can do today.
Wow.
So there's a real revolution of new technologies coming in. It's very, very, very exciting, and I'm really happy to be part of this. And I think it's amazing that China are investing so much in this, and it's really the right thing to do. So
since we talk about development, let's talk about the development plan here in China. QUEST, as we explained earlier, which is the abbreviation for Quantum Experiments at Space Scale. It is one of the China's National Space Science Center's strategic priority program, as they say. It is the third in a row of the firsts for the Chinese Academy of Sciences in terms of science satellites in space. Take a look at this. Following the Dark Matter Particle Explorer satellite, which explores the origins of the universe, and Shijian 10, which experiments with microgravity in space. Quantum experiments at space scale, or QUEST, is the third. The fourth is what they call the Hard X-ray Modulation Telescope, to be launched later this year, aims to observe the universe based on X-ray and gamma ray emissions. Wow, all of these sounds extremely exciting. Only hearing their names could make me already feel very much looking forward to the future. Professor Young from the UK said it's going to change the future because we are coming into a quantum time, a quantum era, as he said. Professor Yang, here in China, what do you make of the enormous amount of investment China has put into the research? I do not know at this moment how much specifically for the quantum research alone, but I do have a number as being reported by the press, $101 billion US for the year 2015. That is for the overall basic research. But 10 years ago, it was only $1.9 billion US. So there's a huge difference there. But will money really bring the difference? How should we understand the breakthrough China managed to make this time with the quantum experiments?
Well, for any
will that be duplicated, by the way, for the other areas?
For any nations, if they do not have much money, they will have applications first, then the basic science. This time, the quantum technology can be developed in China just because we have come into the stage that we can invest some money on the basic science, because in application field we have already been practiced, such as the navigation satellite and remote sensing. So it is the right time for China to invest money in this basic science, such as the quantum technology and those for the science in space science. So, and this will have direct reward in the near future, I believe.
But of course, development in one area does not necessarily going to mean China is going to be advanced in all areas. That we have to be very clear-minded here.
Absolutely.
And Mr. Ghosh, I know you want to say something. Go ahead. What does that mean for the United States, which I understand $200 million US being invested into the research of quantum experiments? Of course, we're not competing here in cash. What we're saying is, how can others, together with China, work together? Mr. Ghosh.
Right, so that is a very difficult question. Working together is not just a decision of scientists. But if you look at the magnitude of the investment, the $200 million, see if this technology works, I think one of the biggest applications is financial transactions. Imagine how many trillions of dollars worth of credit card transactions which are insecure. Like if you look at a departmental store, what's happening is hackers are just stealing one file which contains 2 million credit cards, and all the credit card information is vulnerable and they're stolen. So this technology could revolutionize financial transactions, and the money being spent right now is absolutely trivial compared to the benefits that will be had. So this is very important to understand that if we can have and I'm sure other countries will catch up once China proves that this is a very viable technology. They'll either catch up or collaborate, but there will be a way forward. So it's a very exciting, to a cashless society, going to a cashless society.
But we need also
need to be important step.
We also need to be cool-minded, as we said, Professor Horack, because technologies can be developed. New discoveries could be exciting. And yet, when it comes to applications into real life, such as what Mr. Ghosh mentioned, which is into the financial services, it could be a long process and really depends on how much willingness there is to develop them for the real life applications. Professor Horack, about that, what would you have to say?
Well, I take the very long view, and you are right. I'm very excited about space, and we have the defibrillator here in case my heart goes crazy. But Misius, this satellite is named Misius, right? This is named after a great scientist 2,500 years ago who did fundamental work. In the long arc of history and in the long arc of investment, look at where we have come, and look at what we can build with our minds and our hands to make a better planet for everyone. This is why I think it's so important that we force collaboration from the ground up. The gentleman in Washington, D.C. is right. Our governments have to decide to collaborate, but at the scientific level, I think this is where we get together, we discuss the scientific ideas, we implement technology, we grow and develop that together to build the opportunity for us to collaborate in a constructive way. So I'm very optimistic, and I think we need to look at the long term, the return on investment, the word trivial in terms of how much money is being put in. That's exactly right, because the long-term investment, not just over 5 years or 10 years, but literally over centuries to improve the quality of life here on Earth for everyone.
If it is a quantum era, as Mr. Yang from the UK just said, that is going to be extremely exciting. And therefore, how is China going to stick to its plan? Because we've seen so many details of new development in other areas as well. And also, how is China going to be determined to develop them into the area in which the people can really make good use of it and really to serve the people, not just government, not just the military?
You know that this satellite has an engineering goal and a scientific goal, and because some of the experiments, such as the quantum entanglement experiment, will not be the first to be applied. So the quantum communication of the key distribution will be the first one to benefit the common people, I believe. And it is not all the area will be applied in 2020, and only some of them.